In annuity due, the annuity payments, the equal payments that occur at equal intervals, are shifted one period. They're shifted to the beginning, meaning that the first payment occurs today. So the previous examples were ordinary annuities or annuity in arrears. All payments occurred at the end of the period. These are sometimes called deferred payments. An annuity in which payments occur at the beginning of the period is called an annuity due. Now, an annuity dues are examples of lease payments, magazine subscriptions, or other type of payments where you would pay up front rather than paying at the end when interest or some type of interest-bearing account has accrued. So, for example, let's say your company is considering leasing a warehouse for 3 years. It will lease it for $3,000 per year, paid at the beginning of each year. And we want to know, if we were to pay it all today, what would be the present value of that lease obligation based on an opportunity cost of 6%. So we can see how the payments have been shifted. These three payments, as opposed to ordinary annuities, now are shifted one period to the left. That's all that's really occurred, but the calculations have now changed. Where numerically we would solve this by discounting each cash flow, we can see that the first cash flow is not discounted at all because it is occurring in today's dollars. And the last cash flow is only discounted 2 periods. We can see that we only have to move 2 periods to get to the present value. So the present value of an annuity due will always be less than the present value of an ordinary annuity, all else held equal. So if we were to pay this obligation off today, those three $3,000 payments are equivalent to $8,500.18 in today's dollars. Let's solve this using our calculator. So we want to, once again, clear time value of money. Ensure that payments per year are set at 1, which they are. And now we need to change our calculator from an ordinary annuity to an annuity due. And we do this by hitting second payment or BGN, and then we hit second set, and that puts that BGN there on the face of our calculator. We would quit, and quitting just means that you're going to exit that function, but we can see that the BGN is still there on the face of the calculator. If you're using a TI 84 or an 89 or something like that, you'll see that at the bottom you can switch from an end to a beginning, and this essentially does the same thing. Now we enter in our values just as we did before. So we hit 3N, 6% is our opportunity cost of capital or interest rate. We have $3,000 payments. I'm going to make those negative just because they represent an outflow. And we want to know what is the present value of those $3,000 payments. So this is where we get our $8,500 and rounded to the nearest penny, 18 cents. So let's take this and look at it if we were to defer these three payments to the future value. I don't think this is really realistic. I can't think of anybody that would say you can pay your rent at the end of 3 years. But if we could, how much would we owe at the end of those 3 years? So numerically solving for this, now we would compound that first cash flow 3 full periods because the first cash flow occurs today. The last cash flow we would compound 1 full period. Solving this using our calculator, going to clear what we had before. I have my BGN here on the face of the calculator, so I know that it's already set to annuity dues. And now I put in my values. So N is 3, the interest rate or opportunity cost is 6. I have 3 equal payments of $3,000, making them a negative or an outflow, and now I compute the future value. So $8,500.18 is equivalent to 3 equal payments of $3,000 beginning today, which is also equivalent in time value of money terms to $10,123.85 3 years from now. Now, how can we say that they're all equal? Because we're assuming this opportunity cost of capital, or this interest rate, of 6%. Now, we can solve for the interest rate of an annuity just like we did for the lump sum. We can also solve for the number of periods as well. Now, this is an interesting problem, and don't take this problem too lightly because it's more complicated than you might expect. You're considering either buying a computer or leasing one at $725 per year. You're going to pay this lease payment at the beginning of every year, so this is an annuity due. The current value of the computer is $2,000, so if I bought it outright, that's how much I would pay for it today. You don't have that much, but you can get a loan for 8%. Which would cost less, buying or leasing? That's a very common problem. In fact, today when you lease an automobile or some other asset, fair lending laws say that they have to give you an equivalent or an applied interest rate. And this is where they're going to solve for this problem. So we assume that the computer is worth 0 at the end of 3 years, so it has no salvage value. And we want to find the return of the lease that the lease is charging and compare it to the cost of debt. So our timeline looks like an annuity due, where we are paying 3 equal payments of $725 beginning today. We know that the present value is $2,000 and the interest rate is unknown. So let's jump right to the calculator solution. So I'm going to clear time value of money. Make sure my payments per year are set to 1. And then I want to make sure that BGN is in the face of my calculator, which it is, because this is an annuity due. Now I put in my inputs. 3 years. I don't know my interest rate. I do, however, know that if I bought that computer today, that it would be worth $2,000. I'm going to make this negative, and it really doesn't matter whether you make it negative or positive. The present value needs to have the opposite sign as the payments. Otherwise, you'll get an error. So now I'm going to make $750 payments. Is that right? $25 payments. We're going to assume the future value is 0, the salvage value is 0. And we're going to compute the interest rate. So the interest rate is equivalent to a 9.02% return. We compare that to the 8% that we would be charged if we were buying this on debt, and we find that it would be more advantageous for us to buy it at 8% or borrow and buy rather than lease, because the lease rate or implied rate on the lease is higher than the rate of the debt. So what will your payments be if you borrow the money and buy the computer? Now we're talking about an ordinary annuity. So we need to essentially start this problem new. And let's turn this into an ordinary annuity by changing those payments to occur at the end of every time period. We still are going to buy this computer in 3 years. We have an 8% rate of interest, a $2,000 payment, and we want to solve, $2,000 present value, and we want to solve for the payment. Now, this is where it's kind of confusing, and this problem is more difficult than you may have expected. We see that the lease payment is $725 with a 9% rate of interest, so we know we prefer the 8% rather than 9%, but our annual payment on this computer is now higher than the lease payment. And the reason is because the payment occurs at the end of the period rather than at the beginning. So you don't have to pay that payment until the end of the period. So that $776 that you're paying on the debt is actually less in terms of time value of money than the $725 that you'd be paying on the annuity due or the lease. And that's where it can be kind of confusing, because we can't just say a dollar is equal to a dollar. We have to compare them in like terms. That's why we compare the interest rate rather than the payment.